Now that we have our basic methods of integration, including substitution, down pretty good, we need to move to some situations where substitution and other methods don't work, and so we need something called integration by parts. So we want to consider these integrals here. Can we use substitution or any other technique? So notice here in this first one, we have x squared times the natural log of x. So we have two different functions. Can we use substitution? Maybe we could say that u is, u is x squared. That would mean that du is the 2x dx. Well, that's not going to work because we don't have 2x dx, all right? So what about if we say u is the natural log of x? Well, then we could say du is, well, the derivative of natural log is 1 over x dx. Yeah, that doesn't work either, all right? So, doesn't work, all right? So we should be convinced, yeah, it was a good thought, but it doesn't work. How about here? Similar idea. X times e to the x. Well, if we say u equals x, then du equals 1. That doesn't work. Okay, and same idea. If we say u is e to the x, well, du would be e to the x as well. And again, these two functions don't have anything to do with each other. So we have two things being multiplied, and we've got to figure out, well, how do we reverse that multiplication, okay? So maybe this has something to do with the product rule. So if we look a little closer here, we'll notice that these are products. Okay, that's the key. So they're products of functions. So if we remember the product rule, it looks something like this. The derivative of u times v is the derivative of the first times the second plus the first times the derivative of the second. So what we want to do here is we want to integrate both sides. So let's see what happens when we integrate both sides here. Integrate this whole thing there, right? Well, when we integrate the left side, we just get u times v, because these are opposites, the derivative operator and the integral operator there. And if we integrate this side with respect to dx and this part with respect to dx, well, these dx's cancel, and we end up with the integral of v du and the integral of u dv. Okay, so then we have uv equals this. So if we rewrite this here and we solve for one of these on the right, let's get this one by itself. We can say this. We get this form. The integral of u dv is equal to uv minus the integral of v du. Now that probably doesn't mean too much here, okay? But we'll see how that helps us, all right? Now the key here too is we've got two functions. We've got u of x and v of x, two different functions of x, all right? So the key here is to choose and define the u and the dv carefully, all right? Sometimes there's more than one way to go, but there's going to be a way that's better. and that'll be 1 dx. What's really going on here, by the way, is we're saying du dx is equal to 1, and then we can multiply this over there. Okay, and we can write it as du is 1 dx. All right. Then we have dv. Well, if we integrate this, we can integrate that easily. And so integrating e to the x is e to the x. Okay. So now we can use our definition from up here. We've got the integral of u dv minus uv, equals uv minus the integral of v du. Okay. So let's write that out. We said the integral of u dv is equal to u times v minus the integral of v du. Something to memorize there, all right? So we've got the integral of u and dv, which we already described here. E to the x dx is equal to u, which is x, times v, which is e to the x, minus the integral of v, which is e to the x, du, and du is 1 dx. All right? So we now have x e to the x minus, and that 1 doesn't matter, e to the x dx. Well, that's easy to take that integral now, and that was the whole point. We now have an integral that we can deal with, and so we have e to the x plus a constant. And there you have it. There's our solution. Okay? So again, the key here is we want u to be something that drops down and simplifies, something that is easy to take the derivative of, but maybe hard to take the integral of. Here, for dv, we want to choose dv to be something that we can integrate. Okay? So, let's try some more.